so I was doing this before and my stuff got broken, my phone, so might as well do it again on my tablet. So the question says, in the chemical reaction, pentane is bond, that means it's oxygen forming H2 and CO2. We'll be writing a balance equation, and we have a series of questions we have to solve. And the first question says, if there was 64 grams of pentane, how many grams of water will form? And I think, because I'm also taking this, and I didn't understand it first, but what I just realized is it's just the technique and the mechanism behind it is just what makes people get confused. So, what the fuck just happened on my phone? So, yeah, sorry. So, I was doing it behind under this, and my phone went off, but let's go. So, I'm going to start over again. So, it says 64, let's first balance the equation, sorry. So we have C5H12, and it was bonded, so we have O2, and it gives us CO2 plus H2O. So we have to balance this, and sometimes it takes me some time forever because I don't know sometimes, but of course I've done this before. But yeah, let's go. We start with the highest carbon. Carbon is always first, so we have 5 carbons, so just put a 5 right here. And we go with hydrogen. Hydrogen is 12 right here. Hydrogen is 2 right here. So we have 6, making it balanced. Now oxygen becomes 6 times oxygen becomes 6, and oxygen 5 times 2, and oxygen becomes 10. So everything becomes 16, and over here you balance it and put an 8. So the thing to help you is just trying to write out the ratio. Because that's what helps. The ratio is, so we have 1 to 8, 5 to 6. That is the ratio. Sorry for my camera, but whatever. So the question say we have 64 grams of pentane. Now the first step we have to do is find molecular weight of pentane itself, and that will be carbon. That will be 6, 7, 12, 5. That will be my calculator. Okay, so I have that, and that will be 72 grams per mole. And we have water, so everyone knows that's 18, approximately 18, sorry. It's 18. And we get solving. So first say 64 grams of pentane were formed. We use how many grams of water were formed. Now the first thing we have to do is find the number of moles of pentane that is in 64 grams. So how many moles are in 64 grams of pentane? So we use the formula like gram per moles. You just use conversion factors. So we have 64 grams of methane. Then you multiply that by 1 mole just to get your mole. Then you have the molecular weight. That's 72 grams. And when you divide that, sorry, I have my calculator. I don't know this offer. 64 divided by 672, and that gives us like 0.8888. It's not a recurring decimal, but it terminates at the end. But let's just approximate that to 0.9. So now we have the number of moles of our guy pentane, and so what do we do next? We go straight to figuring out what happens with water. So what is 6? Look at that. What is 6? That's 6 right here. And the problem people make is when they're finding molecular weight, they try to use the 6 to find molecular weight of water. And I don't know, there could be a way to do that because all this is just in ratio factors. But I don't know how to do it that way. So I'll just show you the way I do it. I don't use the 6, and I've never seen anyone use the 6, but I'm sure there might be some fucking Einsteins, whatever, that uses the 6 to solve it, but whatever. So what we're going next? So what do? We've just put 0.9 moles of our homie pentane. You multiply that by the water. So you have 6 moles of H2O, and you divide it by 1 mole of C5H12. So you put a C5H12 right here. So this cancels out. Bam, bam, bam. So you're left with 0.9 divided by 6, 10, 6, 16. So that'll be 5.4 moles of H2O. And now we could start solving. So you said how many molecules of, no, how many grams or whatever form. Now you just do the gram per mole. Or you have to do just 5.4 moles of H2O multiplied by, because we can find the grams, right? 18 grams per mole divided by 1 mole of H2O. So the one you always want goes up. So we want gram, the unit that you want goes up. So these two cancels out. You do 5.4 multiplied by 18, and that gives 97.2. Bam, bam, bam. 97.2 grams of H2O. That's simple, right? So I'm gonna do the second one, and how many molecules of oxygen, and and make another video for the last one. So how many molecules of oxygen were needed? So now molecules, the one you have to bring in is 6.02 times 10 to the power of 23 and the fucking bullshit. But you also start with the same pattern. You always start with the same pattern because that's what was born, my nigga. You start with your pattern, then you start going again. Sorry, I'm high right now, but let's go. You start going with the 0.9 moles you got from the pattern. That should be your starting point. Always use that. Let's use that as a foundation to solve all the problems. Like I said, there may be another way, but fuck it, I don't know the other way. So you have 0.9 moles of C5H12, and all you have to do is multiply that by the ratio. Simple ratio. 8 moles of O2. This is the key, man. They help. Sorry, this is the key, man. All this ratio, they help. So you have 8 moles of O2. Now, what do we do? 1 mole of pentane, C5H12. I think I'm a bad teacher, but I don't know. 0.9, they cancel out, and you have 0.9 multiplied by 8. Calculator comes in. Thank God for calculator. I wonder how people back then didn't use calculator and did all this shit. Like, fuck it. Anybody got time? 7.2. I think we're good. 7.2 moles of O2. So we have 7.2 moles of O2 used. And the question was like, how many molecules? How many molecules? Bam, all you have to do is use the fucking conversion stuff. 7.2. What do you know? 6.02 atoms. 6.0 atoms, 1 mole. Let's go cracking. 7.2 moles of O2 multiplied by, I hope I'm doing this shit right. Wait. Yeah, I guess so. 6.02 times 10 to the power 23 divided by 1 mole of O2. They cancel out. And you do 7.2 multiplied by 6.02 times 10 to the power 23. 7.2 times 6.02. Sorry, I'm slow with calculators. So that gave us approximately 4.33 times 10 to the power 24 molecules of O2. Bam, 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 bam. Thank you.